interested in the field that they're going into, and then they become problem solvers, right? Where you will not let it go, right? You're persistent to the point of almost annoying. All right, I'm going to keep going. I'm preaching here. All right, so check this out. Watch what happens. I'm just going to work through the bottom first, okay? 1 over theta is going to distribute here, and what does that become? It's just theta over theta, which is 1, right? So let me write this fraction down here. So this to here became a 1. I'm ignoring that for now. Now, when I go here to here, that's the one that's really kind of cool. Because I could split that one up. Do y'all see what I did? I split these two apart, sine theta over cosine theta like that. And when I brought this 1 over theta in, I just dropped the theta underneath the sine. And I did that because that's going to turn that into a 1. You'll see it? Now, sitting out front here is still this sine theta over 1, isn't it? But I still have not done this right here, have I? So I'm going to push that all the way across to this one. And what happens when this multiplies times this? What does it become? Sine theta over theta, right? So this really becomes sine theta over theta. So I'm asking you to see a couple of things right now. That when you multiply this times this, it becomes that. And that when this distributes through, that becomes a 1. And then splitting that into 2, the theta can just drop underneath the sine. And now we have no problems. This turns, now when I take the limit, I have to take the limit now. Limit theta goes 0. When I take this limit, that goes to 1. Then 1 over 1 plus, that goes to 1. And 1 over cosine of 0. Cosine of 0 is 1. So 1 over 1 is 1. So what is this? Yeah, it's 1 out front times 1 over 1 plus 1. So your answer is 1/2. So it's number 55. I mean, it's one of the last problems in the section. It's supposed to be a bit of a challenge. I won't give you something like that on a test. Maybe as a bonus, that would be a bonus type problem on a test.
How long are your tests usually?
Well, for this class, we are going to do our test. I think on the calendar, I have them scheduled on the same day as a lecture. So we have to decide as a class. Unfortunately, because this is a summer class, we are not going to take a test that goes from 1 to 4:30, right? A 3.5-hour test. We're not going to do a test that's that long. So there probably will be some sort of lecture before the test, but it'll be stuff that won't be on that test. What we have to decide as a class is, are you actually going to pay attention to me? You know, like if we're going to take it, like let's say we're going to take a test today, right? And we're going to take a test in about 30 minutes. Are you going to be actually paying attention to this, or are you going to be sitting there looking at the stuff that you need to know for the test that you're about to take, right? I don't know. It's difficult in the summer to figure out how to put the test in. But to answer your question, it'll be at least 2 hours. It'll be at least 1 hour 40 minutes. So I could do the test before the lecture. The drawback to that is that some people are going to finish real quick, and then they've got to hang out and wait for everyone else to finish, right? So that's what we'll have to decide as a class. What would you rather do? Come in, knock out the test, and then wait for the other students to finish? Or do you want to do the lecture and then we all take the test at the same time? So I'll let y'all think about it. Those are the two options. We'll vote on it. We still have a little bit of time, right, before our first test? Not much, but 12 days? So not this upcoming Tuesday, but the one after that is our first test. And remember, we only have how many? 3? We only have 3 tests. Would y'all like to take a 3.5-hour test? I mean, I can make a test 3.5 hours long if you'd like. I personally don't want to grade a test that long. I mean, right? I don't want to grade 40 problems. And I'm sure you don't want to take 40 problem tests. So, all right, we are done with 1.4. Right, we're putting 1.4 away. And we're going to move into 1.6. 1.6 is called limits involving infinity. So if you have your calculator out or nearby, please get it out. I would like to do a little exercise in a few minutes. Or we can do it now. Let's do this exercise right now. If you have your calculator, go ahead and break it out. I want us to look at this limit. Limit x approaches 0 of 1 over x. This is like a foundational, fundamental limit that everyone needs to understand. If you can understand this limit, it really helps you understand calculus in a more broad manner. So look what's happening here. As x goes to 0, the numerator is just the number 1, right? So the numerator is not changing. The numerator is, I'll call it fixed, right? It's just a fixed number, isn't it? In fact, it's not only fixed, I'm putting a little plus here because that's telling you it's a fixed positive number, right? So the numerator is stuck at 1, and that's a positive number. And now we're going to divide it by what? 0, yes? Now dividing by 0 is undefined, right? So it's impossible for me to actually plug 0 in. But in a limit, what I'm doing is I'm trying to get closer and closer and closer and closer to 0, right? So imagine on a number line, here's 0. I would like us to approach 0 from, well, this doesn't say which side, right? We have to check both sides. So let's try from the right first. So I need to pick some numbers that get close to 0 from the right. So somebody give me a number that's close to 0 from the right. I heard 1. I heard 0.1. So let's start with 1. Okay, get your calculator out, plug 1 in. What's 1 divided by 1? You don't need your calculator. 1, right? Okay, now get a number closer to 0. I heard 0.1. 0.1, not 0.01. 0.1, right? Okay, do that on your calculators. 1 divided by 0.1. What's that? 10. What happened? It got big, right? Let's get a number even closer to 1. What's 1 closer? 0.01 would be closer, right? Do that on your calculator. What's 1 divided by 0.01? 100. So what's happening here? If we take a fixed number, right, that's positive, and we divide it by a number that gets small, and that number is positive as well, right? All these numbers on the bottom were positive numbers. Positive, positive, the tops were positive, right? The number on top doesn't change. The number on the bottom is getting smaller and smaller, always a positive number. That ratio is getting what? Huge, right? Huge and positive. And we talked last class that I'm never going to run out of numbers here, right? I can go 0.001, right? If I do that in there on our calculator, 1 over 0.001, that's going to be 1,000, right? And I can just get closer and closer and closer and closer. So what happens here is that as long as this denominator number is positive, the ratio will be a big, big positive number, right? Now, that's coming from that side. What if we come from the other side? So what if I come in from here? So start with -1. What would happen if I plug that in here? I'd get 1 over -1, which is -1. Okay, get closer. -0.1. Plug that in. -10. Right? Then plug in a number even closer. -0.01. What would you get? -100. So what's happening now? They're getting bigger, but negative, right? Getting huge negative numbers. So what you need to understand as a calculus student is that when you're talking about a limit, if your numerator is fixed, not changing, and your denominator is getting small, that ratio gets huge. Say that again. If you have a fixed number on top and your denominator gets small, the ratio gets huge. The question is, does it get huge, positive or negative? That just depends on which side you're coming in from, all right? Take out your sheet that has the boxes in it that I gave you last class. Yep, that little. If you look at the bottom left corner, see the bottom left corner where it says fixed over 0, and it gives you 4 different scenarios? That's what I'm talking about right now. I'm talking about if you take a limit and your numerator is fixed in positive and your denominator is going to 0 in positive, then you will have something becoming positive infinity. Oh, you have it in front of you, yes? Okay, so what would the answer to this be, by the way? Does not exist. Why? It's different from each side, right? So from this side, we were getting numbers that were getting bigger and positive, right? So it goes to positive infinity. And then from this side, it goes to negative infinity, which matches the graph of that, right? So the answer to that would be does not exist. So in this section, we're talking about limits involving infinity. This is what we're talking about first, okay? So I'm going to give you a limit right now. What's the limit as x approaches 2 from the right-hand side of 3 plus x over 2 minus x? So what's the first step for any limit? Just plug in. That's called direct substitution. See what you get. What do we get up top? 5. What do we get on the bottom? 0. Okay. Is it 0 over 0? No. 0 over 0 would be algebra trick, right? Here we're getting a fixed number over 0. That's different, right? So we're going to defer to our chart there. We have a fixed number on top, right? And is that fixed number positive or negative? It's positive. Now, the denominator is headed to 0, isn't it? We already know, right from this, fixed over 0 means the top is fixed, the bottom's getting small. We know that this ratio gets huge. It's just a question of if it's positive or negative, right? That's all I need to know now. Is it positive infinity or negative infinity? The way to determine that is to figure out if these numbers down here are positive or negative, right? So this is what you have to do at this point. Draw a number line and put your number that you're going to here. 2. Which side are we approaching from? The right. Just draw some little arrows coming in here. I would like for you to take just a sample number to the right of 2. Someone give that to me. It needs to be kind of close to 2, but 2.1. 2.1. So if I take 2.1, right, I could get closer, 2.01, 2.001, 2.0001, right? But no matter what, if I pick a number to the right of 2 and I plug it in right there, what would 2 take away 2.1 be? Positive or negative? 2 take away 2.1 would be negative, wouldn't it? Even if I would have used 2.01 and plugged it in here, it would be what? Negative. I already know that this is getting small. I already know it's going to 0. The question was, is it going to 0 through positive or negative numbers? Y'all following me? So this is headed to 0 through little negative numbers, right? Because this 2 minus 2.1 would be negative 0.1, and that's a negative. And that would have worked for any number to the right. I would have always had a little negative piece left over. So according to your chart, if you have a number on top that's fixed and it's positive, and then you're going over a negative infinitesimally small number, you get negative infinity. Yes?
So would it just be the opposite of like...
I wish it was. It's not, you can't, on these problems, you cannot just look at what this is and determine the answer. You have to look at each problem because they could be uniquely different. And I can make problems where it wouldn't do what you think. If that were the case, if it were like always the case where you just look at that, and if that's positive, then the answer is negative, and if that's negative, then the answer is positive, then that's the way I would present it to you. But unfortunately, we have to investigate each problem because they could be different. All right, let's try this. So I'll reiterate again. We'll take a break here in just a minute. Let me reiterate this again. When you're taking a limit, if your numerator is fixed and your denominator is headed to 0, that ratio is headed to either positive or negative infinity. Although, if you're doing a limit from each side, then the limit may not exist, like the one we just did for 1 over x. Okay? But we know that fixed over 0 is going to become a huge ratio. Or that ratio becomes huge. So how about this one? Limit x approaches -2 from the left of x squared, sorry. How about 1 minus x squared? 1 minus x squared on top over x plus 2. First step, let x go to -2, right? To -2. So if I put a -2 right here, right, and square it, what's -2 squared? 4. So 1 take away 4 is -3. Good. The top is headed to -3. Hey, that's a fixed number, right? It's positive. I mean, sorry, it's not positive. It's negative, but it's fixed. Now the bottom is headed where? 0. Right now, I can tell you that my answer is either infinity, negative infinity, or possibly it doesn't exist. It would depend on if the limit was coming from both sides or not, right? So anytime you take a limit, you get fixed over 0, you know there are only 3 possible outcomes. We have to determine what it is, though. We have to determine the outcome. So for here, we know this is fixed. We know it's a negative number. The bottom is headed to 0. We just don't know, right? Is this a plus or a minus? Is it little tiny negative numbers or is it little tiny positive numbers? And so the way I'm going to determine that is to draw a number line. The place I'm approaching is -2. And I'm approaching from which side? The left. So that means I'm coming into -2 from here. All right, so I need somebody to give me a number that's here, and I want you to be careful because I'm trying to trick you.
-1.9.
-1.9?
-2.1.
-2.1? See, I'm trying to trick you. Think about your number line, right? This goes, here, 0's here, right? So -1's there. So -1.9 is actually on this side, right? You see how that can be tricky? You have to remember that when you're on this side of the number line, when I'm over here, it's actually going to be something like -2.1. Be looking for that on a test, right? Because I want you to know which side of the number you're on and where you are. -2.1. And that goes into this to check to see if I'm getting a positive or a negative. And in this case, it's negative. Right? If I do that, I get -0.1. Hey, that's the same thing that happened last problem, right? It's not always that way. I made up the problem, okay? So that's the way it worked out. So that means I'm headed to 0, right? But through negatives, not positives. So my answer should be what? My numerator is a negative number, right? The denominator is small, tiny negative numbers. Negative over negative is positive. So you're going to have a huge positive number. This is going to be positive infinity. That's on your chart, right? It shows that, so you don't have to remember it. But I prefer you think about what you're actually doing, right? You have a negative over negative, it's positive.
So if it was a positive number at the bottom, it'd be
Negative infinity.
Okay,
Yep.
gotcha.
Yep. Okay, so did this one do? Yeah, this one actually, right? It was minus here, and it came out plus. So let me give you an example of one that doesn't do that. All right, how about this? Let's do the same exact problem. Same exact problem, but I'm going to do this. There, I'm going to square the bottom. What does that change here? We'll give you a second to write it down. Does the limit on the top, does that change? Is this still headed to -3?
Yes.
Yeah, that's still the same. Is this still headed to 0?
Yes.
Yeah. And 0 squared is still 0, right? So that's still headed to 0.
Any number down there has to be positive.
Yeah, but now I don't need my number line. I don't really need to think about this because it doesn't matter what happens in here because I'm going to wind up squaring it. And so if it turns out positive, who cares? I squared, it's still positive. It turns out negative, it's squared, it's still positive. So I don't actually have to do any more work. I know that this down here is going to be a positive number. It's going to be a tiny positive number. And so a negative divided by a positive will be negative, and I know it's going to infinity or negative infinity already. You understand? Let me ask you, would this change the question, or would this change the answer at all? If I take away coming from the left. Now you have to check both sides, don't you? You have to check both sides. But it won't matter which side I come from, because again, this right here is going to get squared. So I'm always going to have a positive on the bottom. So that would have no impact on the answer. It would still be negative infinity. Okay, let me get to the notes. This is 1.6. So this is, I'm not going to go through all these, but basically this is the same, everything that I just talked about is pretty much here. So I said, look, this was that first example I gave you, the 1 over x. If we came in from the left, 1 over x looks like this. So if we came in from the left to 0, it goes to negative infinity. From the right, it goes to positive infinity. And if I tell you to come in from both sides, the answer would be does not exist because it's going to different infinities, right? And so that was one of the first examples. This is kind of to try and convince you that anytime you have fixed over 0, you're going to get one of these 3 answers. Sure. You want me in it or no? I'm just kidding. I'm just kidding. All right. So there's that. And then, thank you for asking, though. This kind of, we turned into this, it's been weird as a college professor to see the evolution of things, right? It's like it used to be where students would ask me, hey, can I record class? They would have a little voice recorder, you know, and then now it's everyone's got phones, so people are just like taking pictures in the middle of class, and some people ask and some people don't. Some people just take pictures, and so I appreciate you asking. But you wouldn't like it if I was just taking pictures of you in here, right? Right? But I'm recording it, so what am I bitching about? But I appreciate it. Okay. So do you recognize with these functions that when we have this infinity thing happening, that's what vertical asymptotes were back in college algebra? Right? A vertical asymptote is where the function would do something like this, or maybe it would go like that, or maybe both sides would go down. So if we look at it that way, we have a new way of defining what a vertical asymptote is. We can say the following. The line x equals a. So if you have a function, and you have here at a this vertical dotted line, we will call this line x equals a. We will call it a vertical asymptote of the function if any of the following are true. So this says, first of all, if we come into a from the left and we go to infinity, then we've got a vertical asymptote. If we come into a from the left and we go to negative infinity, then that's going to be called a vertical asymptote. If we come into a from the right and go to negative infinity, we're going to call that a vertical asymptote. If we come into a from the left and it goes to negative infinity, we're going to have vertical asymptote. If we come into a from both sides and it goes to infinity or negative infinity, we have a vertical asymptote. So the new definition of vertical asymptote is just that we've got some line where when we come in from one side, it only requires one side to be called a vertical asymptote. If at least from one side we get infinity or negative infinity, then we have a vertical asymptote. I will abbreviate vertical asymptote with a V and an A instead of writing it over and over. All right, so take a look right there. Obviously, that function has a vertical asymptote at 0. You'll agree? Comes in from both sides. Make this just a little bit smaller. Okay, let's look at another one. Obvious, yes? Because from both sides of 0, you got going to infinity or negative infinity. Look at this one. Do y'all think we have vertical asymptote there? Yes. Why? We only need it from one side. Okay? That's all we need to be called a vertical asymptote. You just need the limit from one side to go to infinity. So from the left, heads to infinity. From the right, I don't give a shit anymore, really, honestly, because from the left it went to infinity, right? So, all right. This section, 1.6, is called Limits Involving Infinity. We have covered half the section for 1.6. What we've seen is that when we take limits, sometimes our answers are infinity, negative infinity, or does not exist. So our answer's one of those three, right? The next part of this section has to do with limits that involve infinity, but in a different way. So let's take a 5-minute break. We'll come back. It's actually technically the halfway point of the class, so we'll take a break, 5 minutes, we'll come back. 5, yes? All right, y'all ready? Get back into it. So like I said, this section 1.6 talks about limits that involve infinity. And the first half of this section, what we were seeing is that, again, when we head to some value of a, that your function could be going up or down to positive or negative infinity. Now we transition to a new idea.